So in this lesson, we're going to take a look at some different properties involving exponents. So if you look at these examples that are on the right-hand side here, and I'm going to start with this first one here, x cubed. So some different terminology things just to share with you first. So this x right here is what's referred to as the base, and this 3 right here is what is referred to as an exponent. So when we're talking about using exponents, we're talking about taking a multiplication problem where what we're multiplying is the same each time and writing it in a shorter way. So when you take x cubed, for instance, x cubed here, what does x cubed mean? Well, x cubed means x times x times x. So a shorter way of saying this right here would be to simply just say x cubed or x to the third power. So for this second part here, 2x squared, remember that there's a multiplication sign in between the 2 and the x here. So 2x squared, that means 2 times x squared would be x times x. And then this last part here, 5 cubed, or 5 to the third power, 5 cubed is simply just 5 times 5 times 5. And anytime we have something like this where we're not talking about variables, we're simply just talking about numbers, this is something I can get an answer to. 5 times 5 times 5 is 125. So if you were talking about trying to do this in your calculator in a shorter way, you would say 5 to the third power. So the exponent key is above the division sign up here. You put the exponent in, and you get 125. So that's just some basic things involved with exponents, with some terminology and some different reasoning as to why we use exponents. So another example here, and this is more of what we're going to start to take a look at, is some different things like this, where we're talking, a lot of focus is on variables and exponents. So for instance with this, what I'm going to start with is x cubed. So x cubed, what does x cubed mean? Well, x cubed means x times x times x. So I have that there, and then I have the times in the middle, and then x squared is x times x. So what I want to do is I want to find what's a shorter way of saying x times x times x times x times x. Well, since there's 5 x's here altogether, the shorter way of saying that would simply to just be x to the 5th power. So that's how you would work something like this out in terms of just a shortcut to follow with something like this. So anytime you're multiplying and the terms that you're multiplying have bases that are the same, so like for instance with this, they're both x's, whenever the bases are the same, the shortcut is simply to just take the exponents and add them together. So we could say here, we keep the x the same, but then 3 plus 2 would be 5, and that's x to the 5th, which you can see is the same answer as that there. So as far as using your calculator to check your answer for something like this, just notice in this problem it never really says what x equals. So when I go to use my calculator to check this, what I'm going to do is I'm going to make up a number for x. Just remember with some different things that we've done with this in the past, if you're going to make up a number for x, just don't choose 0 or 1 for x. So you want to choose a different number than that. So say I pick, let's say, like a 3 for x. So I'm going to put a 3 and I'm going to store that in for x. And then what I want to do first is I want to type in the question, which for this one, this was x cubed, right, times x squared. And I want to get an answer to that. So this 243, this would be if I had a 3 in for x and I did 3 cubed times 3 squared, that would be 243. So then after I do that, what I want to do is I want to type in what we said the answer was, which was x, try that again, this was x to the 5th power, and just make sure that those answers match each other. So that's just something, it's not going to do the problem for you, but that's something that you can do in your calculator, that when you get an answer, just something you can do to check to see if it's right. So that's sort of a basic sort of problem there. It just has a single variable and some exponents. Well, some other things that we do with this is when there's more than one variable in the problem. So let me first just go through with you how to work it out. So take this part here, this a squared b cubed. So remember, a squared means a times a. B cubed is b times b times b. So that's that part there. And then I got the times in the middle. And then I got this right here. So ab squared would just be a and then b squared is b times b. So from here, I'm just going to take the variables that are the same and I'm going to put those together. So a shorter way of saying a times a would be a cubed. And then a shorter way of saying b times b times b times b times b would be b to the 5th power. So you'd have something like that there. Now, as far as shortcuts go with this, I'm going to apply the same sort of shortcut that I did with the previous example, but just notice with this, I'm going to stick to keeping a's with a's and b's with b's. So if you take a look at this right here, I got a to the 2nd power, this is b to the 1st power. So because their bases are the same, the shortcut would be is I can add those exponents. So 2 plus 1 was 3, so that's a to the 3rd. And then for the b's, I got b cubed, b squared. So since the bases are the same, they're both b's, I can add the 2 and the 3, and that would be b to the 5th power. So you can see here I get the same answer when I use the shortcut as when I work the problem out like that. So that's an example where there's 2 different variables. Some other things that we look at with this, and that is, well, what if we put numbers in front of the terms? And these numbers that are here, this 3 and this -4, those are referred to as coefficients. So first, just going over how to work it out. So if you take 3x squared, right, 3x squared means 3 times x times x. And then I have the times in the middle. And then -4x to the 4th would be -4 times x times x times x times x. So I have that there. So now I'm going to multiply together the terms that are alike. So I'm going to start with the coefficients, the numbers in front of each of the terms. So I have 3 times -4, that's -12. And then I'm going to put all these x's together. So I have x times x times x times x times x times x. So if you notice, there's 2 here, there's 4 here, that's 6 altogether. So that would be x to the 6th power would be a shorter way of saying that. So as far as shortcuts go, sort of get rid of these here. So as far as shortcuts go, what I want to do with this first is I want to multiply these coefficients, these numbers that are in front of the terms. 3 times -4 is -12, and then I take the variable part here, right, because the bases are the same, because they're both x's, I'm going to add the exponents. 2 plus 4 would be 6, so that would be x to the 6th power, and you can see there I get the same answer as when I work it out. So that's sort of the shortcut version with something like that there. And then another thing that we kind of do with this is we have 2 different variables and coefficients, numbers in front of the terms there. So just notice with this first term, there's no number in front of the x, so I'm going to put a 1 there, just like we've talked about with previous problems like that. And then this y right here has no power there, or no number showing for the exponent. So I'm going to put, this would be y to the 1st power for something like that. So this right here, I'm going to start with this would be -1 times x squared is x times x, and then y to the 1st would just be y, and then I got the times in the middle, and then this part here, this would be -2 times x times x times x, and then times y times y. Now I'm going to multiply the terms together that are alike. So once again, I'm going to start with the coefficients, the numbers in front of the terms. So I got -1 times -2, that's +2. And then I got the x's, so a shorter way of saying x times x times x times x times x would be x to the 5th. And then for the y's, a shorter way of saying y times y times y would be y to the 3rd power, or y cubed. So if we were talking shortcuts with this, what we would do here is we would say, I got the 1 in front of the x and the 1 for the power for the y. So I would start with the coefficients. -1 times -2 is +2. Then I would go to the x's. X squared, x cubed, because they're both x's, because the bases are the same, I can add the exponents. 2 plus 3 would be 5. And then for the y's, I got y to the 1st, y squared. Bases are the same, so once again I can add the exponents. 1 plus 2 would be 3. So you can see when I do the shortcut, I get the same answer as I get when I work something like that out. So most multiplication type problems we're going to look at involving variables and exponents are usually going to be one term times another term. So you have like one term here times another term here. But sometimes we can also do something that looks like this, and we'll kind of finish up with this example here. So notice this has not 1, not 2, but 3 terms that I'm going to multiply together. So with this, I'm still going to follow the same sort of principles that we were talking about before. There's just a little bit more to multiply together with something like this. So the first part here, this would be 5 times x squared would be x times y, and then times, and then this part here would be 3/5 times x cubed, which would be x times x times x. And then the last part would be negative 4y squared. So this would be negative 4 times y times y. So I have that there. So once again, I'm going to start with the coefficients, the numbers that are in front of the terms, and I'm going to multiply those together. So I have 5 times 3/5, that's 3, and then times negative 4 would be negative 12. So that's what I get when I multiply those. Now I'm going to move on to the variables. So the next thing I'll move to are the x's. So I have a shorter way of saying x times x times x times x times x would be x to the 5th power. And then for the y's, a shorter way of saying y times y would be y cubed. So that's the answer that you get for something like that. So as far as the shortcut goes, right, I'm going to still kind of keep the same thing that we did before. So I'm going to start with those coefficients, the 5, the 3/5, and the negative 4. So when I do 5 times 3/5, that's 3, and then 3 times negative 4 is negative 12. So I have that there. Then I got the x's. So I got x squared, x cubed. So because the bases are the same, I can add the exponents. 2 plus 3 would be 5. So that's x to the 5th. And then this is y to the 1st power. So for the y's, I have y to the 1st, y squared. So since, once again, the bases are the same, I can add the exponents. 1 plus 2 would be 3. So just notice when I do the shortcut there, I get the same answer as when I work it out. So that's another just different type of example there, where instead of just having 2 terms to multiply together, we have 3 terms. But just notice the process that we followed with that is exactly the same. So just some steps to kind of put together with this. So these first 2 steps are things that you want to take a look at in the problem before you start to multiply anything together. So this first one is, I'm going to put a 1 in front of any term with no number there. And I showed you one of the examples where you had to do that. And then also we're going to put a 1 in for any variable that has no exponent there. So that's also, we talked about some different examples as far as that goes too. So as far as the multiplication goes, the first thing I want to look to do is I want to look to multiply the numbers that are in front of each of the terms, and those are called coefficients. Not every problem that you're going to look at is going to have coefficients, but if they do, you need to multiply those together. And then finally, we're going to add the exponents of the variables that are the same. If the bases are the same, you can add the exponents. That's the shortcut that I was showing you after I showed you how to work out each of the different types of problems. So that is one of the types of multiplication problems that we're going to look at. In the next lesson, what we will take a look at is a different type of multiplication problem involving what are called double exponents.